The Basics of Metals and Steels by Jeremy Jocelyn. Histories of steel in construction. Prior to the beginning of the 19th century, metals had little structural role in buildings. The first of all metal structures was a cast iron bridge built in the late 18th century across the Severn River. Steel was rare and expensive until the 1850s, when the Bessemer process was introduced. After steel had become more economical, the Eiffel Tower and skyscrapers in the United States had begun to be built. The material steel. Steel is any range of iron alloys that contains less than 2% carbon. Structural steel, or mild steel, contains less than 0.3% carbon and other trace elements. In ferrous metals, iron-based, too much carbon makes hard, brittle steel, or cast iron. Too little produces malleable, weaker material like wrought iron. Mild steel was optimized for structural steel by controlling the amounts of carbon. Steel is created by a process beginning with smelting, then using the basic oxygen process. Carbons and other impurities are burned off. Metallic elements are added to eventually create a finished quality of steel. The process takes less than an hour. Most structural steel is made from recycled material today. Steel alloys. By adding other metallic elements, strength and other properties of steel can be manipulated. Some steel alloys can be produced stronger and cheaper in today's mini mills. Some steel alloys can also be produced to resist weathering and do not need protective coatings. Steel properties can also be adjusted after being shaped with thermomechanical process. Production of structural shapes. Structural mills or breakdown mills reheat a beam blank as necessary, then pass it through a section of rollers that squeeze and shape the steel into its final shape pieces, and they are cut into length and cooled. The shape of structural steel can be adjusted by adjusting rollers. Previous American standard beams were limited to shape possibilities and was succeeded by wide flange shapes. Structural shapes are identified by two standard nomenclatures, by using depth and pounds per foot. Cast and cold work steel. Cast steel, although most structural steel is rolled, it can also be cast by pouring molten steel into molds and allowing to cool. It is more expensive pound per pound, but can be economical for parts needed in small quantities. Cold work steel is steel rolled or bent cold, causing steel to gain considerable strength. It can be shaped into hollow tubes, square, rectangle, or round and elliptical. It can also be used to produce high-strength steel cables. Open web steel joist. Most common hot and cold rolled shape used to support floor and decks, open web steel joists can span up to 144 feet. There are three ways to join steel members: rivets, bolts, and welds. Rivets are steel fasteners that are worked when hot and hammered down to clamp pieces together, although they are not used anymore and replaced by the other two methods. Bolting uses high-strength bolts that are tightened to spec to hold pieces together. Welding uses electricity that melts together base metals and usually a filler metal. There are many forms of welding and types of welds. Details of steel framing. Typical connections. Most steel frame connections use angles, plates, or tees as transitional pieces between members. The joining connection between the web of the beam and the member is called a shear connection because it resists shearing forces. The joining connection between the flange and the member are called moment connections that resist bending forces. Stabilizing the building frame. There are three types of systems used to stabilize against lateral forces: braced frames, shear walls, and moment-resisting frames. Brace frames use diagonal bracing relying on shear connections with two different orientations, regular and eccentrically. Eccentrically are spaced out connections to create more resistance. Shear walls are stiff walls made of concrete, steel, or reinforced concrete masonry. They act much like diagonal bracing. Moment-resisting frames rely on stronger moment connections between beams and columns. Do not rely on diagonal bracing or shear walls. Tall buildings use arrangements of these stabilizers. Shear connections and moment connections. American Institute of Steel Construction identifies three types of beam-to-column connection. Fully restrained under normal loading angles between members will not change. Partially restrained are not as rigid as fully restrained, but are dependable and predictable. Simple connections or shear connections are unable to resist rotation and have negligible moment resisting capacity. These frames must be supported with diagonal bracing or shear walls. The construction process. Steel building frames start out as rough sketches, and throughout the design process, more finished drawings are developed and sent to the fabricator. The fabricator gets the drawing from either the engineer or architect and begins to make shop drawings and determine beam and column length and type of connections to be used. Shop drawings are submitted to the architect or engineer for review. Fabricator orders steel and begins to assemble pieces for construction with welding, connecting systems, bolt holes, and etc. The erector, responsible for assembling building frame on site, also known as iron workers, start with setting the first two-story tier of framing. Base columns are set and bolted into place. Then beams and girders are bolted into place. Floor decking or netting is used every 2 stories for safety. Then the next 2 stories follow a very similar process to the first 2. As each story is placed, they are plumbed and squared. The final piece placed is usually involved of some sort of ceremony. Floor and roof decking. Prior to metal decking systems commonly used today, concrete floors are poured over arch supports. Metal decking is as simple as thin sheet metal corrugated to increase stiffness, but can be increased in strength also by welding multiple pieces together. Composite decking is a lightweight steel decking corrugated and ribbed to support and bond with concrete, making a lighter, stiffer, less expensive frame. Concrete decks are created by either pouring in place or with precast pieces that are lifted and set into place. Roof decks can be made with just corrugated sheets that are waterproofed, or they can be insulated and covered by lightweight concrete. Architectural steel. Architectural steel that is left exposed after the construction process, and usually has high finish standards because it will be seen by people using the structure. Finishes for light gauge steel. Any finishes used for wood framing may also be used on light gauge steel framing, but only screws may be used to fasten finishes to the frame. Key terms and concepts for light gauge steel framing. Light gauge steel is a thin sheet metal, usually bent and shaped into useful and stronger pieces, used in items such as steel floors and roofs or wall studs. Cold formed metal framing at room temperature using light gauge steel. Machines feed sheet steel through and bend and shape it into linear members that are stiff and strong. Bending it at room temperature also strengthens the steel by realigning molecules in the steel, ranging in sizes from 10 to 25 gauge and coming in 3 different pieces: studs, channels, and tracks. Non-structural metal framing, ranging in sizes 20 to 25 gauge steel that does not have any structural value or purpose. Key terms and concepts for cutting. Flame cutting torch. In steel work and construction, a flame cutting torch uses oxygen and acetylene to heat up steel to a melting point, then blow high pressure oxygen to make a clean cut. Plasma cutting uses electrically charged gases and pressure. Gases create an arc, melting the metal, and then blow away the cut material. Developed in the 1950s for metals that could not be cut by flame torch, like stainless, copper, and aluminum. Laser cutting uses high-powered laser or light source that passes through a series of mirrors, then can perform items such as cutting, engraving, and even welding. Key terms and concepts for connecting. Welding uses 2 similar metals that are melted at high temp to form together and create a bond. Brazing can be used to join 2 metals that are not similar. It uses a filler that melts at a lower temperature than the metals being joined, that is used with wetting or a flux to clean metals for better bonding and promotes flow of the filler. Soldering is a step down from brazing, using a metal that has a melting point of less than 840 degrees Fahrenheit. Soldering also is a filler metal that is used with flux. Key terms and concepts for galvanizing. Galvanic protection, using 2 different metals to prevent deterioration of one and sacrifice another to deterioration, using a conductive medium between the 2. Hot dipped galvanized is a protective system using a zinc coating to coat iron or steel. Zinc is usually heated and melted at 840 degrees Fahrenheit. Then steel components are dipped in and coated. Electrogalvanizing is another form of galvanizing in which electric current is used to move molten zinc onto steel. Mechanical galvanizing is a process performed at room temperature where the zinc coating is not put on through electricity or hot dipping.